compound inequalities. Compound inequalities deal when we have two equations and we need to satisfy both of them. And you're going to see them written in two different ways. You're going to see them written as ands and you're going to see them written as ors. And you want to get used to how they look. Now, if it's an and, it means that it needs to both be greater than -3 and it has to be smaller than 6. You'll always see them with the x in the middle. And then there's a smaller term on the left, there's a larger term on the right, and they're always going to be less than symbols. When you see that, we call those the in-between ones, okay? So what you're going to do is you'll either have two graphs that maybe go like that, and at this point, that's where they intersect moving forward, so these don't work. You might have them where one's going this way and another one's going that way, and so it's the in-between here is where they intersect. And so we'll do a few problems to see if they make sense to you. So as I look at this one, I see my -3, and so I'm going to write -3, and it's greater than. So it's going to go, I'll write it on top here. It's going to go that way, right? And then it also needs to be less than or equal to 6. So I'll do a 6 there, and I'm going to do a dot there because of the equal sign, and that needs to go that way. So when you think about it, what you're going to get, where does it solve both of them? And the answer is it's the circle there, it's the dot there, and it's everything in between. So whenever you see an and problem and it shows it with the x in the middle, you're going to do something that's in between. Okay, that's how these are going to work. The or problems, these are going to be what we call the outies. Okay, so it's going to work for either this or that. It's not going to solve both of them. So the example right here, x is less than or equal to -3. I'd have a -3 right there, and I'd put a dot because of the equal sign, and it's going to be less than, okay? And this one is going to be greater than or equal to 2, so there's a 2. I'm going to put a dot there as well, and I'm going to shade this way. So when you have the or problems, they're usually going to be what we call the outies, okay? And so when you get an answer, it'll either work for this one or it'll work for this one, but it won't work for both. So does 8 work? Yeah, because it works with this. It doesn't work with that, but it does work with this. So 8 would be a valid answer. Would 2 be a valid answer? Sure. How about 1? No. How about -5? Yeah, it doesn't satisfy this, but that's okay because it has to satisfy this or this, not the and. So that's why the and, it's taking the two lines and putting them together. They've got to satisfy both. On this one, you have two different lines because it's either, okay? Now, let's do math with some of these. Let's start by doing math with some and problems, okay? So let's erase the board and clear it out. Okay, so let's look at these. Now I have a situation where the x is in the middle, but I have numbers on the outside and on the inside, but I want my x to be by itself. So the thing getting away is that +4. Now just think about solving equations. What would you do? You would go -4, you're going to do the opposite, +4, what's the opposite? -4. Cool. You can do that to this, but then now where do you do it on the other side? With an equal sign, you just go to the other side. With an inequality, you just go to the other side. But here I've got a side here and a side here. So what do you think we do? Good point. We're going to do it to all three of them. So there's three sides. There's a left, there's a middle, and there's a right. We're just going to do it to all of them. And when you put it all together, add a line, change a sign. I'll do that with a different color, so that makes sense. Add a line, change a sign, unless you're colorblind. Sorry about that. Okay, go with the more grayish one if that's the case. So here we're going to go -6. We're going to keep our signs. That's just going to become an x because they go away. Boom, and that becomes 2, and that becomes our answer, okay? So whatever you do to the middle, it's fine. Just make sure you do it to the left and the right. Let's take a look at this one right here, okay? So let's go ahead and, just like any normal problem, what the problem was that? The first step would be is you want to get the x value by itself, so you want to get rid of the 6. It's +6, so we want to go -6. -6, -6, and -6. You do it to all three. They go away. Here I'm going to get add a line, change a sign, -9 less than or equal to 3x less than or equal to 6. Cool. Now I've got the 3x. What would you do in a normal equation? You would divide by 3, which is fine, but you got to do it here and you got to do it there. Boom. -3 less than or equal to x less than or equal to 2. And that's how we would solve these problems when you get the and ones. That's the in-between ones. Okay? What about some ors? Let's try that. Okay, here's one OR problem. But remember, on the ORs, they're really just two separate problems. So in this case, we're just going to treat this like a completely separate inequality. So I want the x value by itself, so I'm going to add 1 to both sides. Boom, die. 6x is less than negative 7 plus 1. Signs are different, so I subtract, keep the sign with a bigger number. Divide each side by 6. X, do I flip the sign? I do have a negative. No, because I didn't divide by a negative. Okay, so if it's a positive in front of the x, he's going to stay. The only time it changes is if that's a negative in front of the x. Doesn't matter what happens to the other side. Okay, got a little funky. Sorry. Boom, boom. So that's half the equation. Okay, the other half is the OR. So here I'm going to go minus 1, boom, die. 2b is greater than 4. Notice how I'm doing it really quick, but I'm still writing it all out. I'm not doing anything in my head. That helps me keep things together. So this is really my answer. Sorry that I wrote a B. There really should be an X going down, right? Because they're both X's. I just got a little bit fancy, too fancy. So now we're going to do a number line. Boom. I'll put my 0 there. Let's go -1. And right here, let's put a 2. And we're just going to write it twice. X is greater than 2. Well, that'll be a circle at 2, and it'll shade that way. And then this one right here would be a circle because there's no equal sign. It'll be less than -1. And that's what my OR graphs look like, okay? So I have 3 worksheets. Go ahead and move down them. Kind of take a look at each of them because each worksheet it's asking you to do things, a little bit differently. So it might be good to go through all the worksheets on there, but this should help you with compound inequalities. By the way, when we get to absolute values, an absolute value problem will turn into a compound inequality. So this is something that's going to really help you with absolute values as well. So learn this, and we'll see you later.